So we're going to start off today with a little GLATOS lecture, and this is coming to us from Ryan Gosse. So Ryan's only started working at the Ocean Tracking Network last summer, but to me it feels like he's been here for so long. He's that integral to the function of the OTN, and he's part of the data crew over there. He has a degree in comp sci. He's also done a lot of research before in oceanography, working with Meridian, and then also the glider group as well. So he really has a lot of experience in different kinds of data types. And he currently is a maintainer of the GLATOS package, actually. So when we were hearing from John yesterday about all of these integrated data systems and how we're trying to make sure that all of these different systems can talk to each other so that we can make more holistic science, Ryan is a key part of that. And so we're really, really thankful to him today for coming to us and introducing us to the GLATOS package and showing us some of the key functionality and how we can really analyze and start analyzing our acoustic telemetry data. So please welcome Ryan.
Thank you so much. Thank you. Okay, so we're going to get started. All right, so if I could get everyone's attention, we're going to get this started. So yeah, I'm doing a little demonstration on how to use the GLATOS package. What you may not know is that even though GLATOS was built for the people at GLATOS, there is input streams for OTN data. So if you have a detection extract, you can actually run GLATOS stuff. So we start off, I'm going to get the test data set. Dets file equals system.file extra data, blue shark detections.csv. And this CSV is literally just a detection extract that we got from our blue shark data project. And then we'll put as another parameter package equals GLATOS. And this will tell the system file function to look into the package GLATOS when looking for this file path. So if we run that, we should get this over here. A little, one of the values will be a string, which is a path to the detections file. And then we can get our detections by just doing dets read underscore OTN underscore detections and pass in dets underscore file. Oh, good. All right. So we're going to reinstall GLATOS real quick. I'm going to get the special My version that has extra stuff. Don't install that one. It's not stable. But it's not unstable that it should be corrupt. Let me get that clear. Yes, while this is running, I'll just continue on. And we just won't run the code. So when we have that data, come on, work for me. The first thing you can do is you can start filtering out the detections that are more than likely false. So there's two steps to this process. The first one is running a function called MinLeg. This function takes, looks at all your detections, groups them by animal, and sees how far apart each detection is from its next detection by the same animal at the same station. So let's see if GLATOS is actually installed properly. This is going to be so bad if it doesn't. Like, oh man. Oh man. All right. No. We're going to get this working. Is anyone else having an issue like that? Beautiful. Just beautiful.
Yeah, mine's working.
Yours is working now. Okay, awesome. What? Okay. Extra data. So, can I actually get a show of hands of who is having the same error as me? Okay, not as many as I thought. Okay. For those who don't have the file like me, you can go to Kim's, sorry, just give me a second, Kim's GitHub repo, and let me see the easiest way for us to get here. Go to my little folder, the RG GLATOS one, and in there, just go to the install R one. We're just going to grab the repo. Down at the bottom here at the install URL, which I guess you already have anyway, just grab all the way up to GLATOS in the URL, and we're going to get the file. I'm sorry to anyone who's connecting online and can't see what I'm doing. Just open up a new tab, why not? Is everyone there that needs to be? Inside of NST or NINST, there's a folder called extra data. And we're using the blue shark detections.csv. And once you have that downloaded, if you can grab the path, for Mac users, you can right-click on the file, hold Alt, and there's copy as path name down here, if that helps anyone. And we'll just replace dets file with the string to the path that we have. And you only need to do this if you're getting that corrupted problem. And then that should so that's still not working for me, and I'm assuming that's not going to work for anyone. So this is good. It's working for you?
Yeah.
And you were having the problem before? Possibly. I'm actually going to turn this mic off for a bit. Okay. I am finally ready again. Stuff is working for me again, so we're going to get this show on the road. Oh, no problem. All right. So, like I was saying before, we're going to filter out some detection. Oh my God, stop. Okay, we're going to so here we go. So MinLeg will calculate the amount of time between detections of the same animal. So, oh, yep, sorry. How's that? Awesome. So what MinLeg does, it will just add another column onto the end of your data set. That's why I just assigned it to the same thing, or the same variable, sorry. And here at the end, you'll have... There we go. At the end, you'll have this MinLeg, and this is the amount of lag between detections in seconds. So this is used in the Pincock algorithm to determine whether or not a detection is false. And the idea behind this is that if there's too long of a gap between detections, and there's only one detection, it's probably false. Getting only one detection on an array is probably just a collision. So this is what we use false detections for. It's another function. And we pass it debts again. And then you can give it a time frame. How long in between pings is it before it's not part of the same event, we'll say. So the standard I've seen is 3,600. So it will print out, when you run this, it will print out a little thing telling you how many of your detections are potentially false. So this is just a function that does a little bit of math. It doesn't know your data as well as you do. So obviously take it with a grain of salt. But if we take a look at debts, now when we go back to the over here, we have another column called past filter. And if we sort by MinLeg and go to the big ones, you'll see that everything that has a MinLeg above 3,600 will be false. So this is just a way to get a list of potentially false detections. But like I said, take it with a grain of salt because you probably know your data better than the program does. So what I usually do after that is I'll go to my good friend the tidyverse, and we're going to make a new variable called debtsF for filtered. We'll go debts, pipe that into a filter, and we're going to say if past filter is not false. Oh, sorry, I'm in Python mode right now, typing out my booleans the wrong way. Cool. And so now we just have, over here you can see detections F, which just has slightly less detections than detections. And we just remove the potentially false ones. Another thing you can do with GLATOS is you can do a couple different ways of summarizing your data. One is just literally with a function we have in GLATOS. So, summary, if I can spell. This is just called, summarize detections. Stop doing that. And all we need to pass into this is debts.
We're getting a couple questions about the false detections function.
Oh yeah, sorry, I'll slow it down. What questions do we have? How does it work? Okay, so literally it just checks to see if that MinLeg is above the time frame that you gave it in.
Yeah, so that time frame is in seconds, right? So
Yes.
you're checking it to see if two detections are outside of an hour of each other, and then so if it passes that, it's considered valid.
Yes.
And they want to be within an hour.
Yeah, within an hour. Yes. Sorry. Yeah.
Yeah.
Yes. It's per array, I'm pretty sure. Let me.
It's actually, the default Pincock is per receiver.
Okay.
And then there's ways to adjust the algorithm to use the entire array or a group of receivers if that's the preference. So you can have a column that defines receivers and then use that as a variable instead of receiver. There is an option that we
To do what, sorry?
An alternate column other than receiver as the...
Yes, as I was just about to mention that, actually. A bunch of the GLaTOS functions will let you specify what column you want to perform functions on. I'm actually about to show in Summarize that, yeah, you can tell it which column you want to use.
Can I just quickly give you a headache?
Yeah.
Don't swear, he's probably watching.
Yeah. Yeah.
The version of this got pushed out by one of our collaborators 8 hours ago. That's why so many people are having trouble.
Oh, yeah. That just clicked for me. Yeah. Yes. Sorry. Yes. So one of the problems we're having right now is that a new version of GLaTOS was literally pushed out 8 hours ago. So that's probably causing us some issues. Yes. Yes. Yeah. The question was, can you use the question is can you use something other than a transmitter ID if you had like a sensor tag or something? The answer is yes. I believe you can. You would have to name the... I don't think you can specify which column to say, like, is an animal. But if you rename the column so it matched, I think it's animal ID, or I can't remember what it is in GLaTOS right now. But yes, you could use anything as your unique identifier. Do we have any other questions? Cool. Yeah, sorry, I'm just going a little fast because of how much time we lost there. But yeah. So, yes. So you can summarize your data with this summarize detections function. But you'll notice this, all these functions are written for, in the original case, these were all written for GLaTOS. And instead of stations, they do arrays of where your animal was found. So they'll have multiple arrays in the Great Lakes. And then over here, there'll be locations. And they'll have all the arrays that your animal was in. But in our case, we just have the one line. We have the Halifax line in this data set. So that doesn't really tell us where anything was. We just know it's in Halifax, in the Halifax line. So, like I just mentioned, we can give it a different column. So, there is a parameter called location column, or just location call. And we're going to say station instead. And then when we run this, you get a much better one where all the locations that you saw, each animal, are in that summary. You also have the number of locations that they were at and the number of detections in total when they were first detected and when they were last detected in this data set. Any questions about this? Nope? Okay. You can also get detection events, as they call it in GLaTOS, from the package. And this is used with a function called detection events. We're going to do the same thing as last time. Dets F, which I didn't do last time, but whatever. And we're going to do a location column as well, because we do not want array. We want station. And the way they define an event is, let me just look at the data so I'm not being completely wrong. Yeah. So it's each animal at each location. An event is how long they were staying there for and how many times they were detected there. So you get, so in this case we have Allison here. She was at Halifax 34. She was first detected this time and then last detected also that time. So there was one detection and we don't know how long she was there for. But then you have other ones like 4 detections. We are able to calculate the time between the first and last detection to create an event of that animal being at that station. And oops. Yes.
What's the threshold in there that says that it's basically residency time?
That's a good question. I feel like it's probably 3,600.
Okay. Can you set that yourself?
That's also a good question. Can you set it yourself? You can, apparently, I've heard. So yes.
Okay.
So yes, you'd be able to define how long between you say, no, this is no longer an event.
Yeah, even though it wasn't detected somewhere else.
Exactly.
It went swimming somewhere.
Exactly. Because yes, we have ones that have gaps of like a year or like days, and it's just like, those are not the same event.
Yeah. It did not just hang out there for 6 months.
Yeah. Or yeah. You can also summarize with this. You can get events. Oops. Event summary. Just using our good friend dplyr again, of course. Events. We're going to group it by animal ID and location, which in our case is stations. And we're going to summarize. We want the number of events equal to the n distinct. Oh, wait, no. Event. We want to get the total number of detections. We'll get the sum of num underscore detections. And we will do total time sum of res time in seconds. And then I've just made a little summary of each animal at each location, how many events there were, how many detections there were, and the total time that we know that they were there for. So yeah, that's just a little simple way of looking at that long list of events in a little smaller way, I guess. More easier to read. Time underscore set? Okay. So yeah, Jake just told me that you can use a time underscore sep to specify the time in seconds, I'm assuming, between events. I'm just going to do 1 second for fun, why not? And it just did it into distinct events. Okay. That's cool.
You set that to an hour or whatever.
Yeah, you could do, I think it's set to an hour by default, but you could do like every minute or something, which still gives the same thing. Do we have a question over here? No? Okay, I thought I heard. Sorry. Never mind. Oh, okay. All right. What else does GLATOS have? Oh, yeah, yes. So we also have a residence index function. This uses the events data frame that we... Stop that. This uses the same events data frame as we created earlier. So we just need to put in events. So we'll take a second. And then we have the residency index for each animal. And it gives every station, so there's a lot of zeros. But and this is an interesting thing. I'm not sure if you've run into this, Jake, or anyone else has used the GLATOS package. But when you have very small zones, like we do, where we use stations, the residency index won't equal 0, or won't equal 1 when you sum them all together. It can be like 2 or 3, because it doesn't understand how you could have a fish in one place, or an animal in one place, and then go to another place, on the same day, but it counts that as 2 separate days. So I'm going to have to talk to Chris about that because I think that's wrong. Because if I summed up all the residence indexes for Allison right now.
Really quickly, what residency index is?
Yeah, sure. But yeah, if I sum these all up, it would be like 2.5, which is more than 1. But yeah, just something to keep in mind. And a residency index is what percentage of time they stayed at that location. So in theory, there should be 100% because you only have detections. Because you can only be at one place at once. But yeah, there's a little problem with the algorithm right now. You can get it a little smaller if you used there's a couple different calculation methods for residency index. But you can pass it, I guess I should be doing this in here. You can pass it a calculation method. There's a couple, there's time interval, there's Kessel, there's 2 aggregate ones I don't remember the name of. I've only ever used Kessel and time interval. But if we did time interval, you can specify how long before it says this is no longer thank you. A resident for the people who couldn't hear. And then you can do time interval size. And this takes in actually a string, so you can give it, say, like 1 hour. And if I did this, it does make it a bit better because it starts understanding that you can split up days. But with the Kessel one, and it's still over a little bit. But yeah, I need to talk to Chris about that one. I just realized that when I was making this presentation. But yeah, if it works better with the GLATOS data where they use arrays and they're so much bigger, so you don't have as many fish transitioning between different stations or locations. But yeah, any questions about resident index or how it works in GLATOS or anything like that? No? Okay. Now I just have a fun plot I want to do. We're going to use ggplot for this because I'm trying to learn ggplot. So we'll go ggplot plus geom underscore point. The data is equal to, I'm using an event summary that I made earlier. Given an aesthetic, x equals location, y equals total detections. Oops. Oops, nope. Color equals animal ID. Size equals 2. And I'm going to add a theme to it, just because the axis will look really bad otherwise.
Can you really make sure that the plot is, the code is higher up? Because we'll go back and cancel the bottom of the screen.
Can. There you go. X equals element underscore text. Oops, not blank. All right, I think I've done this right. Oops, that's not what I wanted. Two font sizes bigger? There we go. You won't be able to see this on the stream, I don't think. I actually don't know what this is going to do to the stream. But yeah, there's a little plot of the number of detections per station per animal in like 3 lines of code. So I'm really liking the ggplot. Yeah, I'm going to bring it back to this. Yeah. See if I can bring this over a little bit. There we go. What are we doing for time? Okay, I got 20 minutes. I think I'll be able to finish it up. Yeah, I think it'll be fine. If not, none of you get coffee. All right. I'm going to continue on here with just some basic plots you can do with GLATOS. So I'm going to use the... actually, we won't mention that just yet. We'll get to that in a second. Don't worry about that. So we can do an abacus plot. All you need to do is pass in debts. And like before, we need the old location column to be station. Otherwise, it just looks hilarious with a bunch of dots all put on the same spot. Figure margins too large. Well, we'll see about that. Woo. There we go. So yeah, this is just a little abacus plot showing you, I'll go back in a second, all the different stations and over time, just where there was detections. We also have another plotting thing, just the detection bubble plot. And this one's a little interesting. I'm going to do it the wrong way first, and then we're going to do it the right way. So, do a location call, station, and if I were to run this is going to pop out on me. Yeah. It just shows us a picture of the Great Lakes with no data. And that's because by default, it will just set the bounding box to the Great Lakes because it's built for the people in the Great Lakes. So we can add a background y-lim, and we're going to do, in our case, 42 to 46, and a background x-lim of negative 63 point, nope, negative 66, and negative 62. I'm also going to grab the raster library because we need a map. Because by default, the only map you can see in the GLATOS map, or this function, is the Great Lakes. So if you resize your plot a bunch, you'll just see like a little Great Lakes off to the corner there. It's kind of funny, actually. Get data. We're going to use the old GADM. I don't know if that stands for anything. Country equals Canada. Or I think I need to do it all caps. And we're just going to get level 1 data because it doesn't need to be that refined. I'm also going to subset this to just be Nova Scotia using Canada $1 equals Nova Scotia. Cool. And then we can pass that in as a map. So it will actually show us a map. Now, if I did everything right, we should get a nice little plot, which I think is going to appear over here. It's going to take a second. There we go. And now we have a little bubble plot with all the detections. Let's see if I can make this a little bit bigger. Yeah, there you go. That's a little better. Bar's a little messed up. That's okay. But yeah, so yeah, you can play around with the location and give it different types of maps. I think it takes any type of map object. You can just put any of them in there as long as it can be plotted with the base R plot function. I'm pretty sure you can use any map you want. So yeah, it's nice for getting little stuff like that. And we can drill down even further and get like smaller areas and stuff just by changing the X and Y limb. All right. Any questions that we have? Marmap? Possibly. If it can be plotted with the base R plot, then yeah. Okay. So do we have any questions about GLATOS? About anything? Cool. I'm going to change gears a little bit here. Don't bother following along with this one, like typing-wise, because it's only my special version of GLATOS that has this. We are currently in the works, or we're doing a couple things, but we're currently in the works in making some crosswalks. And the first crosswalk we're doing is, I'm actually just going to copy and paste this because it's going to be a lot easier. We're working on getting some crosswalks to different types of platforms. So our first one was VTrack, written by the people in Australia. And okay. So I just copied a bunch of code, but so what we can do, hopefully in the next version, and it actually might even be in the version you all have now, because it just got released 8 hours ago. Now that I just thought of that, yeah, right, so you might actually have this. But we can crosswalk over to VTrack. Their format is called ATT. And there's a couple weird things with getting over to VTrack, because with GLATOS, you literally just need to give it your detections and you're ready to go. But with VTrack, they want this data object that has your detections, your deployments, and all the animal information. So we had to do a little bit of finagling to get all that data in. We're using a pretty basic format. We are using the tag and deployment metadata sheets that you fill out when you do a deployment. And then it reads those and gets it into a format that is closer to the ATT. And then we can use it. And then we can make the full thing. So the first thing we do is just read in detections just as normal. There's a prepare tag sheet. This is the path to your tag, the tagging sheet. The two parameters, I don't remember what both of them mean, but one of them is which line to start on. And, yeah, right. One of them is the first one is which line to start reading from, and the other one is which page to read from, because we're Excel files, you can have like so many different pages. It needs to know which one. So that should, yep. And then the deployment sheet, same type of thing, but the deployment sheet's a lot less variable, so there's no parameters to pass in how to get that data out. And then we have this new function called convert OTN to ATT, and if that works properly, this is what the ATT format looks like. You have all your tags, or all your detections in here. It's all tibbles. It's can I see this? Yeah. Yeah, so this is all your detections, all your tag metadata, all your station information. And then with this, we can use library, VTrack, and we can use their functions like they have a, what does COA mean? Centers of activity, that's what it is. So yeah, they have a centers of activity function, and then I'll show you what that data looks like. So yes, it's per hour, like where the number of stations they were at, how many detections they had. and then all the animal metadata tacked onto the end. So yeah, that's coming down in the future, or it could be here now. I don't know. And yeah, we're hoping to get more crosswalks to different platforms, so people can easily get from one telemetry analysis package to another. And that's all I had. Anyone have any questions about GLATOS in general, anything like that? VTrack, I don't know too much, but I know a little bit. Yes?
The abacus plot, is the x-axis the duration? Like, is it your timestamp, or does it do the intervals? Can you
It's
repeat the question in the way?
yes. So the question was the abacus plot. Does it use your time, or does it use even intervals? I'm pretty sure it uses your time, but let me take a little quicker look here. Yeah, I'm pretty sure it's your timestamps. Yeah. Anything else? Any other questions? Yes.
In VTrack,
Yeah.
the ATT functions, and I haven't done it in a couple days, but I was talking to Robert, and the HR summary isn't working.
Okay.
I was wondering if you play with that at all.
The question was that in VTrack the HR summary isn't working.
Yes. Basically any of the ATT functions that they encompassed.
So how did you install VTrack? The way that
Yeah,
through the GitHub?
yeah.
Okay, that's strange.
Yeah, you have the same issue, right?
Yeah.
Oh, were you low battery? Oh, this low battery. Oh,
I'm just
okay.
basically asking everyone this question, so.
I have used it before and didn't have an issue. The problem with
All
the
like you were using the ATT functions that they
Yeah.
have? Yeah, okay. It must be then just an issue, right?
yeah.
I got a special request from the stream to try to make this thing show up on it. So hang on a sec. I'm going to be a jerk.
Okay. Yeah, I don't know exactly how the install GitHub works, but they may have broken something because I think it just pulls from master, but I'm not 100% sure. But yeah, I can take a look at it in a bit if you want.
Sure, yeah, maybe I'll pull up my code.
Cool. Yeah. Yeah, sure.
If it works, I'm going to be really tired tomorrow.
Okay, no, I have no idea how to capture the proper window. I'll get out of your life.
Okay.
I'm sorry.
It's okay.
Where were we? Where's the deal? My bad.
No worries. Sorry to the people on the stream that don't get to see the plots. Yeah. So, oh, now I've messed everything up. There we go. Here we go. There we go. So I had a request to go through the vignette for VTrack for the HR summary. So we're going to give that a try, see if it works, since it's not working for everyone.
No, that's why I felt they're bad at it, but Robert just said it's working.
Oh, it's working for Robert now? Okay.
I definitely didn't mean to hijack this.
No, I'm done anyway. Just even. Okay, that time it works. Okay. Cool data. Ah. No, it's just warnings.
It's important to read the warnings as well.
I think it ran for me. I'm not really sure. I don't remember what the data is supposed to look like. But this looks rightish.
It ran better than it did
Okay.
last few days. Brian, appreciate it.
What are some of the other functions in GLATOS that are common or that are able to work on?
So yeah, one of the things that I didn't get to touch on for other things that GLaTOS has, there's a lot of functions for helping you deploy your receivers. Let me just get a list up so I can read from it. They have stuff like for calculating collision probabilities. They have a way to simulate detection of acoustic tagged fish crossing a receiver line or a single receiver for helping to find the optimal spacing between receivers.
You can play with things like tag programming and receiver distance to
Yeah.
get a good idea. Like you can throw a bunch of these program tags across this arbitrary receiver line. What is the likelihood that you miss detections, or what kind of how well will you capture detections on those tags programmed that way
Yeah.
on that receiver line? Not taking into account range conditions.
Yeah, and I'm not sure how well it's been tested for oceanographic data, or if it matters.
I don't think it's ready to take on variables like that and start to adjust.
Yeah, because I think they use it mostly in the Great Lakes for when they do a deployment. Do I have any more questions, or have I bored everyone thoroughly? All right. Well, thank you everyone for listening to me, and sorry for all the hiccups. I guess that's what happens when you do a release 8 hours before a workshop.